Hello everyone and welcome back. In this lesson, we're looking at an introduction to logarithms. And so for this lesson, what we're going to be doing is to introduce logarithms and go through the basic information that we need to make sense of them and to make sure that we can use them properly. First thing we want to do is to define what the logarithm is. And the best way to do it is to start with this equation 2 to the x equals 32. By inspection, you can see that x is equal to 5 because the exponent of this base 2 that we need to produce 32 here is 5. So we'd say 2 to the 5 equals 32. We can also say that the logarithm to the base 2 of 32 is 5, and we can write it this way. Log to the base 2 of 32 is equal to 5. The word logarithm can be used synonymously with exponent. And so each logarithmic equation corresponds to an equivalent exponential equation. That is, the logarithmic equation y equal log to the base a of x can be written as an exponential equation in the form a to the y equal x. Now look at these two here that have been compared side by side. Notice that both here we have log to the base 2, and here in the exponential equation you have 2 as the base. So 2 is the base, and y is the exponent. And of course, 32 is the number that you get when you raise base 2 to that exponent. So each logarithmic equation corresponds to an equivalent exponential equation. So logarithms and exponents are closely related. What we're going to do here is to rewrite each of these log equations in exponential form. Now let's look back quickly here. Notice that the logarithmic equation 2 to the y equals 32 can be written as log to the base 2 of 32 equal y. So this is the base, this is the exponent, and this is the number that is brought to the base of 2. So log to the base 2 of 32 is equal to y, corresponds to 2 to the y equal 32. Let's use that. So we have to raise the base to the power. So we can say in this example, 9 raised to the 3 over 2, that's the power, is equal to 27. And in this one, we're going to raise this base to that power. So 1 over 25, let's put that in a bracket, raised to the negative a half is equal to 5. So we can write a logarithmic equation in exponential form, and we can also write an exponential equation in logarithmic form. So here we have an exponential equation. We're going to write it in logarithmic form. And so this is the base. So we're going to write to the base log to the base 7 of y is equal to negative 6. And in this case here, log to the base 8 of this power, log to the base 8 of 1 over 4 is equal to negative 2 over 3. So we can write an exponential equation in logarithmic form, and we can write a logarithmic equation in exponential form. And you should be able to go back and forth between the two. Now let's evaluate this expression, log to the base 7 of 1 over 49. Now let's write that down. So first, before we solve it, we need to make this equal to something. So let's, for example, let this equal to x. Then we can say 7 to the x, switching it back to exponential form. 7 to the x is equal to 1 over 49. And then we can ask ourselves now, what number do we need to raise 7 to in order to get 1 over 49? That is, we can rewrite the equation 7 to the x is equal to 7 to the minus 2, because 1 over 49 is equal to 7 is equal to, let's just rewrite it a little bit. 1 over 7 squared, which is the same thing as 7 to the minus 2. And therefore, we can say that x then is equal to negative 2. So this is how we could approach something like this. Let's look on some properties of logarithms. Now, if b, m, and n are positive real numbers, that's important. That's because the domain of a logarithmic function does not include negative numbers. That is, you can't find the log of a negative number, although you can get in the range negative numbers. Negative numbers just cannot be put in the domain. They cannot be used as inputs. Now, if b, m, and n are positive real numbers, where b is not 1, and p and x are also real numbers, then these following properties of logs are true. Log to the base b of 1 is 0. And if you want to rewrite that, then you'd say that b to the 0 is equal to 1. And as you remember, any number apart from 0 raised to a 0 power gives us 1. 2, log to the base b of b gives us 1. So if you're finding the log to any base, and that base is the same thing as the number here, then the answer is always going to be 1. Third, log to the base b of b to the x is equal to x. And again, if you want to rewrite this as b to the x, so if you try to rewrite this in the exponential form, b to the x, you will see that it's actually equal to the here, which is b to the x. And fourth, b to the log of bx. So notice these two, b to the log of base b, b to the log to the base b of x is equal to x. That is, of course, x has to be greater than 0 because the negative numbers are not used as input in the log function. Those are just basic facts that we need to know and remember. We're going to go through a few more of them, but these are important to remember as just basic facts. Fifth, here we have the product rule. The product rule is important. The log to the base b of mn is equal to log to the base b of m plus log to the base b of n. And we simply say it as the log of a product is the sum of its logs. So the log of a product here is the sum of its logs. Notice that we're using the same base across here. Log of a product is equal to the sum of its logs. The log of a quotient here is equal to the difference of the logs. So here we have the division rule or the quotient rule, which says that the log of a quotient is equal to the quotient of the logs, or is equal to the difference of the logs. All right. And the last one here, which is the power rule, which says if you're raising a number to another power or something to a power, whatever the thing is, then the log of a number raised to an exponent is the exponent times the log of that number. So log to the base b of m to the p would be equal to p times log to the base b of m. We're going to be using these in a moment to try and simplify some stuff and to get us more familiar with them. So here we're going to look at some other facts related to logarithms. And when we say logs, we normally mean log to the base 10. But of course, you could use any other base for logs. So if you use other bases, then those bases have to be stated. And one of those other bases that are popular and are used a lot is the logarithms to the base e, which we call natural log. So logarithms to the base e are written as ln. And so we have e to the x would be equal to y. That's the logarithm and the exponential equation that is connected to it. And so these are just some more facts that we need to be familiar with. Again, the log of 1 is always 0. Whether you're using the log or you're using ln, which is natural log. And you can use either, depending on the question. You can use either of them. They will both give you the same results. Now, the log to the base 10 of log of 10 is equal to 1. Of course, when you say log, it's to the base 10. So log of 10 is equal to 1. Same thing for natural log to the base e is equal to 1. And log to the of 10 to the x is equal to x, because here we're dealing with log 10. Saw it a while ago in the properties, and the same thing here. The ln of e to the x is equal to x. And of course here, for log 10 to the log x, of course that's going to be equal to x, as long as x is greater than 0, and e to the ln x is equal to x. So these are just some very important facts that we need to remember. Remember that the input has to be greater than 0, because we cannot put negative numbers in the input in the domain of the log. All right, let's just use them now to see what's going on. So this says log to the base 2 of a plus log to the base 2 of b. And what we want to do is to write these as a single log. So we're going to use the multiplication rule to deal with this one. Remember, we said the log of a product is equal to the product of its logs. And so in answering a, the log to the base 2 of a plus log to the base 2 of b is simply equal to log to the base 2 of ab, because the log of a product is equal to the sum of its logs. Here we have the log of is a difference, and for that one we're going to use the quotient rule, which says that the log of a quotient is equal to the difference of its logs. So here we're going to write the log to the base 10 of y. So this is y divided by y plus 1, y minus 1. But then you need to ask yourself, what do you do with this 2 here? So let's remind ourselves a little bit here. So if you have log to the base b of m to the p, remember, then this p is multiplied, p multiplies the log of m. So that's what we're using there. So we're going to have then, let me just rewrite it a little bit first. So first it would say log to the base 10 of y minus log to the base 10 of y minus 1 squared. That's really what it's saying, because this 2 is a power. And so then you can rewrite it as log, here we go, log to the base 10 of y over y minus 1 squared. So we can use those logs to rewrite the stuff. Here's another one, c. And c says half log to the base 3 of x to the 10 minus 2 over 5 log to the base 3 of x to the 5. Now remember, this is a power and this is a power. So we can rewrite this first as log to the base 3 of x to the 10, and that is raised to the half, minus log to the base 3 of x to the 5th power, and that is also raised to 2 to the 2/5. And that tells us that we're dealing with log to the base 3 of x to the 5 minus log to the base 3 of x squared. And we can simply rewrite that as log to the base 3 of x to the 5 over x squared, which can also be further simplified into log to the base 3 of x to the 3rd. So just using the rule to write it and then rewrite it and following the basic algebra that we know, simplifying this, simplifying that, and so it all boils down to this one. All right, let's continue. So here we have the log of a product, and we want to write it out using logarithms. So if you want to write this out, then remember that the log of a product is equal to the sum of its logs. So here we're going to have log to the base 2 of 2 plus log to the base 2 of a plus log to the base 2 of b. Log to the base 2 of 2 is 1. So we can write that as 1 plus log to the base 2 of a plus log to the base 2 of b. A log to its own base, log of something to the same number here, that will always give us 1. Now let's look at b, that's a. So the logarithm to the base 4 of x to the 6 divided by y to the 5th power, we can rewrite that as, it's a quotient, so we're going to use the difference of the logs. we're going to say then log to the base 4 of x to the 6 minus log to the base 4 of y to the 5th power, and then we're going to take the 6 and use it as a multiplier, same thing with the 5, and so we finally write this as 6 log to the base 4 of x minus 5 log to the base 4 of y. And so we can take the product rule and expand this product here to write it as the sum of its logs, or we can also use the coefficient rule to write this log as a difference of the logs. So the log of a product is the sum of its logs, and the log of a quotient is the difference of the logs. And we can use our basic mathematics that we know already to apply simplification to them and work them out as they appear. This is how logs work in basic detail. Of course, there's a whole lot more information to deal with on logs, that is to look at logarithmic functions and how they behave, and to solve logarithmic equations and how they behave. If this is your first time looking at logs, then you probably want to spend some more time looking at the basics before you get into solving equations and stuff like that. That's it for now. Please remember to practice and to improve your skills. And of course, if you haven't subscribed to the channel, then please do. Thank you for watching as always, and thank you for your support.